Okay, so we have created the universe. Let's now create our solar system. And the theory that explains the creation of our solar system is called the nebular theory. Just a quick heads up. Be sure that you don't get these two things mixed up. The Big Bang Theory is the theory about the origin of the universe. It happened 15 billion years ago. It took about 10 billion years for energy to transform over into matter, it to cool down enough and lower enough in energy that now the matter can come together. So the nebular theory took place about 5 billion years ago, and that is the theory about the origin of our solar system. Now, the solar system started off as a nebula, and if you're a science fiction fan, you probably know what a nebula is. It's a big cloud of dust and gas and maybe some rocky stuff. Um, because energy is dropping, gravity is going to take over, and all objects that have mass have gravitational attraction towards one another. And so this gravitational attraction happens, and the pieces start coming together, and we call it a gravitational collapse. And for our specific solar system, that happened about 5 billion years ago. Now, be sure to watch the animation. I've embedded it in the PowerPoint. I've included it in your weekly folder. It's really pretty cool to see this in action. What happens is as this material starts to come together, it kind of spins out into something that kind of looks like a frisbee. It's a flat disk. The sun is in the center. And then what we're going to have is a bunch of debris on the outside of that center part of the sun, and that debris will actually eventually become our planets. The inner planets are pretty different. They're metallic, rocky, and the outer planets are gaseous. So the lighter stuff was out towards the outside of this spinning mass. So here you can see the picture. I've got it animated. It's kind of like a ice skater in the Winter Olympics. When you start to spin, you start spinning really slowly. And when that ice skater wants to speed up, they don't move their feet like Fred Flintstone riding his Flintstone mobile. All they have to do is pull their arms in. And by pulling your arms in, you make your center of gravity much smaller and it ends up spinning faster. And so here we have it, it's spinning faster. In the third picture down in C, you guys can see that we've got some discrete paths, and they just look like a bunch of debris, and those are going to actually become our planets for the most part. Okay, in the D figure, you can actually see those discrete paths. The material in them, the rocky material actually, or the gaseous material, will have gravitational attraction also, and it will come together. Finally, in E, you can see the solar system as it is now. So yeah, it did take a little bit of time to change over. All right, now we are going to go on a tour through our solar system. You guys, we've already talked a lot about the sun. You've already had an in-class assignment about the sun. Remember, the sun is the only star in our solar system, and it's a very average star in that medium heat, medium size, medium lifespan, etc. We're going to talk about our 8 planets and some of their satellites or moons. We're also going to talk about Pluto. And remember, when you were young, Pluto was a planet. And only in the last, I don't know, 6 years or so has Pluto been demoted, and it's called a dwarf planet. We're going to talk about the asteroids. And if you guys noticed in that nebular theory animation, one of the rings never became a planet. And that's the ring that is our asteroid belt. And it lies between the inner rocky planets and the outer gaseous planets. All right, we're going to talk about comets, and I kind of have a thing for comets. And we're also going to talk about meteoroids, meteorites, meteors. You may call them shooting stars. Believe me, you do not want a star shooting through your atmosphere. Okay, it wouldn't even get anywhere near close to us if we were all dead. When you see what you would think of as a shooting star, it's just a little bit of space debris coming through our atmosphere and burning up and making a pretty spectacular show. All right, here is a diagram of our solar system, and you can see obviously not to size scale and really not to distance scale either, but it just gives you a nice depiction. Sun is in the center of our solar system. Now you guys remember, 400 years ago I would have been burned at the stake as a witch because that was blasphemy to say that. And actually Galileo was put under house arrest and excommunicated from the Catholic Church for figuring that out. We're going to talk about the characteristics of the 4 inner planets. We'll talk about the characteristics of the 4 outer planets. We'll talk about the asteroid belt, and you guys can see that there. We'll also talk about Pluto, and if you check out Pluto right now in this diagram, you can see why Pluto was demoted. Pluto is 2 things. Pluto is really, really small, and those outer planets are really, really big. Also, Pluto has what we call an eccentric orbit. All of the other orbital planes kind of lie flat, and Pluto is actually tilted at about 17-degree angle. We'll also find out that Pluto, for about 20 years, Pluto was actually closer to the Earth and the Sun than Neptune was. Okay, so we'll get to that. Pretty cool. All right, so we are going to start to go through the planets and take a tour. Now you guys just kind of listen, and at the end I have 2 slides that will summarize the characteristics of the inner planets versus the characteristics of the outer planets. And it's kind of the big picture that matters, not the really specific stuff. I will not ask you to name the 8 planets in order. You know, when I was a kid I had to learn it, and what I did was I made up a little saying. My very excellent mother just served us 9 pizzas. Now, obviously, with Pluto gone, I'd have to change that. No more pizza. My very excellent mother just served us noodles. So Mercury, Venus, Earth, and Mars, my very excellent mother, those are the inner planets, just served us 9. Jupiter, Uranus, or Saturn, Uranus, and Neptune. And so it's actually pretty easy, but don't worry about it. We're going to learn the real basic stuff at the end, but we're going to kind of talk about what makes the inner planets and what makes the outer planets the outer planets. Now, the inner planets, Mercury, Venus, Earth, and Mars, they are small, and this is all relative. They're big compared to you and I, but they're small compared to any of the outer planets. They're dense. Rock is more dense than gases and ice, and like I said, they're rocky. Now, we're going to talk about this too. We are only capable of holding on to heavier gases in our atmosphere because light gases will be burned off into space. We are too small and too hot to hold on to very light gases including hydrogen, helium, like that. All right. The outer planets, they're also called Jovian or Jupiter-like, are gaseous and icy. They're very much larger. Because they're much larger and much colder, they're far from the sun, they can hold on to very small gases or low density gases. They have thick atmospheres of these low weight gases. And as of, there you go, there's the date where Pluto was demoted. All right, this is to scale, but obviously not spaced out. According to scale, the sun is absolutely huge. Mercury is absolutely small. And in fact, we're going to find out Mercury is now the smallest planet once Pluto got the boot. So you can see 4 inner rocky small planets, hotter, closer to the sun, and 4 outer gaseous planets, larger, colder, and made up of gases and ices. All right, Mercury. Now, Mercury is really cool. I'm going to show you guys a picture, and you might say, oh, that's a picture of the moon. No, it isn't, actually, but Mercury and the moon have kind of similar histories in that we're going to be talking a lot about erosion on Earth. And we have erosion on Earth. I also call it the giant eraser because we have an atmosphere and we have a hydrosphere. So we have a gaseous atmosphere and we have liquid water on Earth. This acts like a giant eraser. Anything that sticks up on Earth, erosion's going to start working on. Anything that's sticking down, it's going to start filling in. Mercury and the moon both don't have atmospheres or hydrospheres, and so their very violent beginnings are really obvious on their surfaces. Mercury is the innermost planet. It's hot. It's closest to the sun. It actually rotates very slowly. Remember, in 24 hours, we make 1 complete rotation on our axis. A day in Mercury is 180 days. So now imagine yourself standing around a very hot campfire, and you can't keep turning around, and your backside's cold, so you turn around and you get your hot front side away from the flame. Mercury can't do that like we can do that. And so there's a huge difference between the day side and the night side in temperature. It is the smallest planet. It has no atmosphere. It is too small and too hot. It cannot hold on to any of those gases at all, heavy or light. Okay, it's very cratered. Remember that animation you saw and that pile of debris, chasing after the planetesimal and bang, bang, bang crash. It was violent. Our planet, and then we're going to find out our moon too, had a very violent beginning. Okay, it's very dense. It revolves quickly around the sun, meaning that, think about a race. If you run a race, you want to go closest to the inner part of the racetrack. Horse races, you see them, they all go to the inside rail because that's the shortest path. And because Mercury is closest to the sun, it's got the shortest path. All right, here is what we call a photomosaic, and when we get to oceanography, we'll talk more about this. When you take high-resolution data, you typically take it in these strips, and then you glue it back together. And not in the planets, but in other data, I spent a lot of time gluing this stuff back together. And we'll talk more about that. And you guys can see all those pock marks? Man, Mercury has bad skin. Those are all signs that there was a violent beginning. Those all are impact craters. All right, here's another shot, and this is the one where it even took me some time to be convinced that this was not the moon. Okay, and it's not the moon. The pattern here is different. The black parts are basalt flows, black lava flows. When we have large impacts back, most of these are, I don't know, 4 billion years old. When you have a large impact, it melts the rock and you get a lava flow. And so we have the same thing as on the moon. Those blacks and then the whites are what we call highlands. And you can see the craters, and that pattern there is very different from any pattern you're going to find on the moon. All right, Venus. I've actually been able to see Venus during the day. It is so bright. The sun's the brightest object in the night sky. Venus is the second brightest. It's kind of called Earth's twin, but I call it Earth's evil twin. Now, when we look at planetesimal geology, why do we look at the planets and think geology? We do that because sometimes the planets could tell us about Earth's past, sometimes they could tell us about Earth's future. And so Venus can show us about Earth's past right now, but I sure hope Venus is not giving us a hint about Earth's future with its atmosphere. So it's called Earth's twin because it's, the second rock from the sun. We're the third rock from the sun. It's similar in size, mass, and density, but Venus is a lot hotter. Venus might be like how Earth was many billions of years ago. When you see Venus, you are not seeing Venus's surface. You are seeing its very, very thick atmosphere. Now, we used to send probes to Venus. Not very smart use of yours and my taxpayers' money. They don't last long. Imagine taking a aluminum can and squashing it. Okay, that's what happens to our probes because the atmosphere on the surface of Venus is 90 times that of what's on Earth. So it gets squashed like a bug. And that's assuming that it even gets into the atmosphere, because as soon as it enters the atmosphere, it's raining sulfuric acid. Actually, the Russians are still sending probes, and I'm not really sure what they're doing. It's not really going to be a place that we really want to go live anytime soon. Now, why do I say about that little warning about Earth's possible future? Greenhouse gases. You guys know about global warming and greenhouse gases. We are putting a lot of carbon dioxide in our atmosphere, and Venus' atmosphere is mostly carbon dioxide. It has what we call a runaway greenhouse effect atmosphere, and it is nasty. Now I'm going to show you guys some cool pictures of the surface of Venus, and the way we got them was through radar. Radar penetrates gases, clouds, ash, etc. It's pretty cool. All right, now when I show you those surface pictures of Venus, you're going to notice it looks kind of like what you might picture hell looking like. It's hot and lava flows and red and fiery. Lots and lots of activity. It is still tectonically active. There's still heat inside. Not a lot of impact craters, even though it had a violent beginning too, because lava flows have filled them in. So just thousands of volcanoes and volcanic structures. All right, here it is, and I'll get in a close-up here in a second. This is penetrating the clouds of the atmosphere, and you can see the hot surface. And kind of think back, Earth's surface at one point kind of looked like this. We're farther away. We just did a little more cooling. All right, and check this out. This is where my little hell analogy comes into. So yeah, this is not real pleasant. You and I are not going to be landing here anytime soon. But again, these are actual radar images of the surface of Venus. Pretty cool. Okay. All right, so this is where Earth belongs, third rock from the sun, and we're going to spend the whole semester on Earth, so I'll come back to that later. We know a lot about Earth already. All right, Mars, the red planet. We spend a lot of time as scientists thinking about Mars. Mars is absolutely fascinating to us. We might look at Mars and think about Earth's future. Now, Mars is small, and Mars is actually cooled off on the inside, so it's no longer tectonically active, meaning that there will never be a Mars earthquake type thing. We have earthquakes because our inside of our Earth is still hot and the plates are moving, and plates did move in the past. The inside of Mars was hot, but it's not anymore. It's cooled off. So again, Mars could be a little bit of a picture into possibly Earth's future. Now, Mars does have an atmosphere, but it's very, very thin. Now, you guys, I'll be using a lot of movie analogies, and I watch a lot of cheesy movies, actually at my students' insistence. They keep asking me, have you seen this movie? Is it realistic? And one of them is our former governor's movie about Mars, and he falls out onto the surface of Mars, and his eyeballs, are popping out, and he's choking, and yeah, you couldn't live on the surface of Mars. There's not as much surface pressure, and there's not enough gas to breathe, much less the wrong gas. And so, not too bad. They must have had some sort of a science advisor there. It's primarily carbon dioxide. Now, I still remember the first time I saw a picture of Mars, the planet, and I was shocked. There are two polar ice caps on Mars, one in the northern hemisphere and one in the southern pole hemisphere. And this has frozen H2O. Okay, and that's why Mars is so exciting. We do not believe you can have life anywhere else in our solar system or universe without the presence of water. And so, again, kind of looking at Mars as being more advanced or farther along kind of the path than us, some scientists really believe that life could have evolved on Mars in the past. And, the presence of water is really pretty good indicator that maybe it could happen. Now, Mars is a really, really windy place. Has lots of dust, lots of sand dunes, and lots of storms. And in fact, this actually has saved you and I as taxpayers a lot of money. We send probes up to Mars to take lots of pictures. And in fact, if you go on the internet, you guys could probably find 1 million pictures or 500,000 pictures of Mars. And so you build this probe and you send it up there and you think, oh, it's going to last about, I don't know, a month because we got to recharge the battery. And when we recharge the battery, we open up the solar panel and we point it towards the sun and we collect energy. But if it's a dusty place, your solar panels get covered with dust, then the efficiency is bad and decreasing as there's more and more dust, and then no more recharging the battery, and you got a dead rover. Those strong winds clean off the solar panels. And so those things are like the Energizer Bunny. They keep going. The only problem is running into rocks and stuff.
Okay, all right, guys, we're going to play a little game. Is it Mars or is it the Earth? The next 3 pictures will either be of Mars or the Earth. And what you need to do is look at the picture, make your guess, and then flip to the next slide. And that will give you the answer.
What do you think? Mars or Earth? Look at it carefully. Okay, it's Earth. There were some tire tracks on there. It's amazing. As a geologist, I actually take students out in places in Death Valley that look exactly like pictures of Mars. All right, what about this? Mars or Earth? Okay, that's Mars. And how about this? Okay, very similar to that last shot. That's actually Earth. So that's kind of a fun game to play. You can go onto a site, pull up a bunch of Mars pictures, put them in with some desert pictures on Earth, and it's kind of a fun game. All right, so Mars is a geologist's dream. Mars has all sorts of signs that it was tectonically active in the past. Mars is home to the largest volcano in our solar system called Olympus Mons, and it's a large shield volcano, much like the Big Island of Hawaii. Okay, now 75,000 feet high, that's like 15 miles, you guys. That's huge. Okay, Mars had a violent beginning too, but because it had been tectonically active and it does have this sediment transport in the wind and things, you don't see as many impact craters. The inside of Mars is cold. It has run its life out, no more earthquakes or plates moving or anything like that. Well, I guess Mars quakes, technically. Now, there are some big canyons, and the canyon that I want to point out is called the Mariners Valley, or Valles Marineris. Now, it's not like the Grand Canyon. The Grand Canyon was cut by the Colorado River. This is more like the Great African Rift Valley. We're going to talk more about the Great African Rift Valley. It's where two plates have pulled apart. And the Valles Marineris, or Mariners Valley, is where the two plates pulled apart in the past, and then when the kind of the inside died out, we're left with this, big crack. All right, this is a bird's eye view of Olympus Mons, the largest volcano in our solar system. All right, here's another shot, a bigger picture shot, and you can see there's several of these shield volcanoes down on the left-hand side. Right in the bottom center, we've got the Mariners Valley. It's a place where two plates pulled apart, and we're going to see a lot more of that sort of action on Earth. We've got impact craters, we've got sand dunes. Now, if you look in very faintly up in the right bottom kind of middle part of it, you see flood channels. Okay, this is what's really exciting. Hydrologists are geologists who study water features on Earth, or features on Earth that are made by the movement of water. And they take looks at pictures taken from Mars, and they said the only way that those features were made is by movement of water in the past. So that's what's pretty exciting.
If you want to see more pictures of what scientists believe is evidence that water has been on Mars, go on the internet and just type in, pictures of Mars or water on Mars, and try and find a government site, and I bet you can find literally thousands of pictures.
All right, and here's that shot where I was kind of saying how neat it is to see the polar ice caps, just like we have, on Earth, to have ice on our poles. All right, Jupiter. We are now on our 4 outer gaseous planets. Yes, we have jumped over the asteroid belt. We'll come back to it. Right now we're covering our planets. And what we're going to see is that our outer planets are going to have really different characteristics than our inner planets. Jupiter is huge. Now, first of all, you guys remember back when we talked about stars, I told you that in fact, most solar systems in our galaxy and in our universe and in other galaxies, there's more than one star. And in fact, most stars are twin stars. There's usually 2 stars in a solar system. You might say, well, that's not normal because that's not what we have. We almost did. If Jupiter had been 10 times bigger, it would have been a small star. So we just, I guess in some ways, we're kind of lucky that we don't have that second star in our solar system, but most of the other solar systems in the universe do have a second star, and so most stars are twin stars. Now, Jupiter, even though it's so large and it's so far out there, remember Mercury took 180 days or so to rotate on its axis for one day. Okay, Jupiter, this huge monster planet, does it in 10 hours. We take 24. And so what it does is it gives it a middle age inner tube or tire around its waist. It gives it a bulge. And so sometimes artists are really nice and they fix that so it's not too self-conscious. All right, here's a shot where I can see that the artist has fixed the unsightly bulge at the waist. Now, because it does spin so fast and it's large and it's gassy, you can see those stripe patterns. And we're going to talk about Earth's stripe patterns when we get to our final section on meteorology and the Earth's atmosphere. But because this is larger and spinning faster and things like that, it has a lot more stripes than what we have on Earth. Now, you see all those kind of circular blobs? Those are actually storms. And in fact, that giant one that's shown is one that Galileo first saw back in 1600 or so, 400 years ago or more. That's pretty impressive. And it means that storms have been going on for at least the last 400 years, and it doesn't look like it's slowing down at all. 3 Earths would fit across that giant red spot. So that's huge. Okay, about 3,000 Earths would fit inside of Jupiter. So it is big. Now, Jupiter is made up of those light gases, hydrogen, helium, that's methane, CH4, and then ammonia. And let's see, we've got the stripes. It's, probably violent atmospherically. We talked about the red spot, which is a giant storm in the southern hemisphere. There were a lot of other storms in there you could see, but the giant red spot we've known about for at least 400 years. All right, now we're going to find out one of the characteristics of the outer planets is they have a lot of moons, okay? Earth has one moon, so inner planets have few or no moons. But the outer planets all have a lot of moons, and Jupiter has more than 60. Now, 4 of those moons are very large, and they were discovered again by Galileo in the 1600s. Okay, you don't have to know the specific information, but if you guys ever are lucky enough when you're walking across campus and you find the astronomy class out observing, ask them if you can look at what they're looking at. And one time I did that, and they were looking at Jupiter, and right in front of Jupiter were 4 ping pong balls. I'm like, hey, what's that? And those were the 4 Galilean moons, and so it's pretty cool. All right, one of them is called Io, and Io actually has ice volcanoes. Okay, if anybody wants an extra credit opportunity, that would be a great topic to write about. All right, Saturn. Saturn's similar to Jupiter. It's large, it's gassy, it's got a lot of moons. Its most famous feature is obviously the rings. Again, Galileo. We got him to thank for it. So his primitive telescope, it sure discovered a lot of stuff. And they are actually really, really complex. So here's just a little bit of a picture of some of the complexity of Saturn's rings kind of spelled out. Don't worry about it. It's a difference in density and materials, which position the rings are taking, but they're kind of interesting. And again, if you guys are big fanatics of astronomy, this would, Saturn's rings would be a great research topic if you want to do an extra credit paper. All right, it's a dynamic atmosphere. It's in motion. The gases are moving. It does also have lots of giant storms and spots similar to Jupiter's. It has 30 named moons. Titan, one of its largest, has caught the attention of scientists because it has a substantial atmosphere. Remember, when we go out looking for signs of life on other planets or moons and in our solar system and outside our solar system, we look for atmosphere and we look for the presence of water. And those are 2 things that get us all excited, thinking, hey, maybe life could be on that planet or had been on that planet or moon in the past. All right, Uranus. Uranus and Neptune are almost identical. They're also considered twins, although obviously Uranus is closer into the sun and Neptune's farther out. They're blue in color, so I'll show you guys pictures here in a little bit, and I'll teach you how to easily tell them apart. And they're both blue because they have that gas methane in their atmosphere, okay, CH4. Now, Uranus is weird in that it does something very different. It rotates on its side versus rotating kind of on the axis like the rest of the planets do. Uranus also has rings, and it's got a lot of moons, and they are large, and they are varying between icy and gaseous and things like that. Okay, here's a shot, and actually Uranus is the boring twin. Wait till I show you Neptune. Neptune's kind of the exciting thing. Lots of stuff's happening on Neptune. All right, and then Neptune. Neptune now is our outermost planet. It's very, very windy. It has this giant dark spot, which is a storm. It's also blue because of the methane. It's going to have these cool white high clouds, and that's going to be one of the easy ways to tell it apart from a picture of Uranus. Okay, lots of moons. One of its moons is really interesting. It's got the lowest recorded temperature in our solar system, and it's actually traveling in the opposite direction. So it's orbiting in a different direction than all of the other planets are. So kind of some weird stuff that our solar system does. All right, and here's the picture. You can see the storms, the giant spots. You can see some of those stripy patterns. You can see the high white cirrus clouds.
You've now been on a tour through our solar system. Now, I don't want you to memorize all these facts about each of the separate planets. What I do want is for you to understand some of the common characteristics that the inner planets have as compared to the outer planets. Planets, Mercury, Venus, Earth, and Mars all share similar characteristics, such as they're rocky, which also makes them more dense. They are smaller. They're also warmer. They're closer to the sun, which is the heat source. They have few or no moons, and the gases that we do have in the atmospheres for Venus, Earth, and Mars are heavier gases. All of our inner planets are just too small and too hot to have enough gravity to hold on to those lighter gases. The outer planets, Jupiter, Saturn, Uranus, and Neptune, also share certain characteristics. They are made up of gases and ices. They are much, much larger than those inner planets. They're colder. They're farther from the sun. They're less dense. Gases and ices are less dense than rocks. They all have a lot of moons. Jupiter has something like 64 moons. Okay, and the gases that make up their atmospheres are much, much lighter gases. Gases that the inner rocky planets, being hotter and smaller, could never hold on to. If there were those light gases in their atmosphere, they'd be burned off into space and probably would end up being grabbed onto by the gravity of the larger planets and held there. So the larger planets have the light gases such as hydrogen, helium, and methane.
All right, Pluto. Pretty exciting week when Pluto was being demoted. The International Association of Astronomers got together, and we're trying to decide what is the definition of a planet. And so during that week, we went between having 15 planets, 64 planets, and finally at the end of the week, we ended up with our 8 planets. They tried to do it just by size and include Pluto, but then that also included some material in the asteroid belt and in the outermost Kuiper belt. Then, I think what they finally did was a mixture of size and orbit. You have to have your own unique orbit, and because Pluto doesn't, Pluto was demoted. Now, Galileo did not discover Pluto. Pluto wasn't discovered until 1930, and really they didn't know a whole lot about Pluto until much, much more recently with the advent of much more advanced telescopes. It's just an ice ball. It's not a giant gaseous planet. And it's got this wacky orbit where, you can see the 20-year period where it was actually in closer to the Earth and the Sun, and then it moves back out into the outer part. Now, don't worry, it's not going to hit Neptune. The first moon of Pluto was discovered in 1978, and since then, 2 more have been discovered. It is cold. It is very, very far from the sun. All right, just kind of a shot here. It is little. So it was once our littlest planet, no longer now. Mercury's our littlest planet because it's a dwarf planet. All right, asteroids. I kind of like that asteroid belt. The asteroid belt lies between the inner rocky planets and the outer gaseous planets. There's the large body, the biggest one is called Ceres. It kind of looks like mutant potatoes, and I'll show you guys pictures. And remember, during that exciting week, about, 5 years ago, Ceres was actually a planet for a day or so. 620 miles in diameter. That's actually pretty big. Some of them have very wacky orbits. I'll show you guys a slide. A lot of those impact craters you see on the moon and the ones that aren't so obvious on the Earth because of the magic eraser were caused by collisions in the asteroid belt. Believe me, we watched this. Armageddon, the movie with Bruce Willis and Ben Affleck. We have the technology. We can go up onto an asteroid and blast it. I just don't know if that's the best thing to do. And the thing that worries people is I think the asteroids in the asteroid belt are going to stay, but if something comes into the asteroid belt and knocks them, it's kind of like a billiards game. And then the balls scatter everywhere, and in this case, the asteroids scatter everywhere, and who knows where they go. Okay, they're irregular, like I said, mutant potatoes, and not really sure about their origin. Is it a failed planet? What's going on here? All right, here's Ceres, ugly potato with bad skin, because it too has been through a lot of micro collisions. Here are those wacky orbits. When we said eccentric orbits, you can see the fuzzy part is the real asteroid belt, and the asteroid belt looks just like they would have it in a sci-fi movie. And the blue orbits are some of the asteroids that are on paths that are constant, and hopefully in the last 4.8 billion years or whatever, they have already knocked into anything they're going to knock into, and things are a little bit more stable. All right, here's another large asteroid that was probably also a planet there briefly in that kind of exciting week when Pluto was demoted. Gaspra. Just really wanted to quickly say that some of those asteroids look more like, I kind of showed you guys a solid one, so they look more like a bunch of grapes clustered together due to gravitational attraction. All right, comets. I like comets. Comets are dirty, rocky snowballs. And comets are formed far from our sun, and I'll show you guys their path. They come in on a path around our sun. You only see comets when they're in close to the sun. The sun is putting out a lot of heat. It's putting out solar wind, and it's this that causes these comets to melt and for the gases to vaporize, giving it that cool tail. So we're going to take a look at some of these diagrams and pictures. Let's go ahead and look at those. Now notice the tail always points away from the sun. It's like opening up a really hot oven. You can just feel that heat radiating off. And so the tail always is pointing away from the sun. And if you look closely, there's actually two tails. The water and rocky material tail is the dust tail that you see there. And the ionized gases is the material that, goes to gas and ionizes off as less dense. And therefore it forms a different tail. Really, really beautiful. Now, I was very fortunate. When I was a little kid, my parents dragged my sorry butt out of bed and said, "You're going to go look at this comet, Halley's Comet." And I was like, "No," I think it was 86. But yeah, I got dragged out and I went and looked at it and I went, wow. Okay, and so we'll talk a little bit more about that one. And since then, when I was a young adult, two more spectacular comets came through California area, or we could see them pretty clearly from California area. And once in a while we get small fuzzy ones. But keep an eye out for it'll be in the news. You want to see these things. They are spectacular, and you want to get away from light pollution. Okay, and I'll explain a little bit more about that here in a sec. All right, not sure about their origins, just know they have to be far from the sun because otherwise they'd be all melted. Most famous one is Halley's Comet, 76-year orbital period. So if you're a historian and you're going back and reading, diaries and historical accounts from every 76 years, they're going to talk about this strange phenomenon in the sky. So yeah, it was 1986 when my parents dragged me out to go look at it, and I hope in 2062 you drag your grandchildren out and make them look at it, because who knows, maybe you'll make a little scientist. So Hale-Bopp, and then there was another one, I think it was Hyatuki, not long after that, pretty spectacular. Hale-Bopp is kind of infamous. Hale-Bopp, I was down in San Diego at that time, and in Rancho Santa Fe in San Diego County, a weird cult, Heaven's Gate, committed suicide because they believed that heaven was on the comet's tail, and the only way they were going to get to heaven is to kill themselves when Hale-Bopp went by. You guys, don't join cults. Use your mind. So not a real sharp thing, but unfortunately Hale-Bopp will always be infamous, but it was spectacular. Check it out. Here's a beautiful shot of Hale-Bopp. And once again, even just standing on the ground in a dark area in San Diego County, you could see the two tails very, very clearly. Now, if you're in an area that's highly industrialized and very bright at night, what I call light pollution, the tail's tiny. But I just went a couple hours into the hills, and the tail was inches longer. I mean, it was spectacular. And so it's just really neat to go see this. All right, meteorites, meteoroids, meteors. I'm not going to test you guys on the difference, but don't call them shooting stars. It's space junk, and it used to all be natural space junk. Now sometimes it's man-made space junk. And when it enters Earth's atmosphere, our atmosphere is a superhero. It protects us. You guys imagine walking outside and then being punched full of a bunch of holes, like being shot by a gun. Okay, not real pleasant. Okay, thank you, Earth's atmosphere. Earth's atmosphere breaks up all of that material, almost all of that material that comes in through the atmosphere and takes it down to dust, so it doesn't punch us full of a lot of holes. If you become an astronaut, you got to worry about this because you don't have Earth's atmosphere when you're out there doing a spacewalk or on the moon or something to protect you, and so you can end up with a hole in you. And actually, one of the space stations was hit and ended up with a hole in it, and that caused a lot of problems. So kind of exciting. Now, meteor showers, we have the Perseids, the Leonids, and actually those are probably what's left of a comet. Because remember, every time a comet comes in, it's kind of being decreased and decreased by melting and vaporizing and things like that. And so they are periodical or have a periodicity. All right, we have a great display of meteorites on the second floor of the Science Museum building on the Rockland campus. So if you guys get up there near the planetarium, go and find it. It's pretty cool. Different sources. I'm not going to ask you guys a test question on this, but you know, anything that would create space junk. And I kind of actually have to add the fourth bullet now because humans. All right, some of them are mostly metallic. You'd pick them up and go, wow, this weighs a ton. Some of them are just rocky, like, you know, a rock you'd pick up on the surface of the earth, and other ones are a good mixture. Now, before you go, just go buy, you know, at Denio, somebody's selling a meteorite. I don't think so. You need to have some sort of a certification or something. And, you know, it's hard to tell, but there are a couple of people that could probably ID it for you. The other thing is that think about these objects have come through the Earth's atmosphere, and so the outside's going to melt and then cool really quickly, and so they have this certain texture to them. But again, if you can, get upstairs and check out our great display. All right, and here is one. And, you know, some people spend their whole lives chasing after these things in deserts and on ice caps and in Antarctica and in the Arctic and things. People find these, and you can find them in your backyard, but, you know, it's a little bit more rare. So pretty cool, pretty neat.